Go.
Hey, I was gonna say you took the words out of my mouth. Thank you, Andy. That's pretty insightful. Aditya, I know you have a little bit of a checkered and happy history with Aurora as well. Why don't you let us know?
Yeah, I've been working with Aurora for the last 5 plus years, and like Andy said, we are not done innovating. But we today have a very special guest, the OG, and like we lovingly refer to him as the father of RDS, the father of Aurora, Grant McAllister. And as much as we want to talk about the future, we want to start where it all began, the innovation of storage. And Grant is going to talk all about that. Grant,
Thanks, sir.
welcome.
Yeah, as I said, my name's Grant McAllister. I'm a senior principal engineer on the RDS and Aurora team. I spend most of my time on Aurora these days, but it's been quite the journey, and we've really come a long, long ways in the last 10, 15 years. I mean, for those of us that managed databases back, 20 years ago, it was handcrafting an individual machine, and ordering it, and waiting 6 months to get the machine in, and doing all this stuff. And
Yeah.
We tried our best, Grant, to
Yeah.
get those machines out.
yeah, exactly.
Then I would love to hear from audiences. What are some of your horror stories from back in the day about the storage and the databases and installations? Let us know.
Yeah, exactly. So, we kind of have that classic architecture from back in the day where actually, most of the drives were actually attached directly, via SCSI and weird things that like people have even forgotten about. But, sort of in a sort of modern classic model is what we built with RDS. And so I'm going to walk through, sort of how we thought about where we were with storage and then how we thought about what we wanted to do. So I'm going to show you this short little presentation just to walk you through that. So on the left, we sort of have a classic architecture. It's still like a good architecture, but there's reasons why we wanted to do something different.
Yeah.
So on the top, you kind of have the head of the database, the sort of processing unit. So when you do a commit as a customer, what happens is you're going to write, and at the time, this was typically to one availability zone before RDS. This was very innovative at the time, was to do multiple availability zones, or MAZ, or is what we call it inside.
Yep.
But the things you're doing is you're writing all the blocks. You got a checkpoint. So there's a lot of work going on, logs, archive logs. There's a lot of processing that had to write. So that pipe was pretty important, right?
Yep.
Now, behind the scenes, typically you weren't just writing to 2 copies because that's not enough durability, right? So you would do chained replication, and that's what I'm showing here. Is that extra copy is chained together. So at that point, you do this because you don't want to have to send 4 times the bandwidth down to the storage, but it does end up with some interesting effects because you have to wait for these acts to come back from storage, right?
Yep.
And that first act gets done, the second one gets done, but let's say this third one kind of stalls for a second, right? Well, that means you've got to wait for that to happen.
Yeah.
And so that can cause a lot of jitter or long tail latency in your application. So it's waiting for that commit. Finally, it happens. You get the commit back to your application. You can process something. So this works pretty well, right? Like, don't get me wrong. Like, it's a standard architecture. But when we started reimagining what we wanted to do with databases in the cloud, where we were going to disaggregate like how the system worked and move more intelligence to storage, we're like, we have an opportunity to change this model, right?
And back in the day, this was kind of revolutionary, that change or the decoupling of compute and storage too.
Exactly. And so there was many things that come with this, and I'm just going to talk about this one specifically, which is really around latency and jitter reduction. There's a lot of other pieces that other folks can comment on, but so you start with the same head node, and again, this is all open source Postgres compatible, right? So there was no big difference. Like, that was one of the key selling points that I really pushed on Aurora was if we want adoption, we've got to be open source compatible,
Absolutely.
right? Because I think that was just real key for our success. So we do that commit. And instead of sending these things down, we send 6 copies right away. Now, the big difference is it's only logs, right? So all the things like checkpointing that always had to happen now are doing that in storage, right? So that's super important. This allows us to have the bandwidth to send those 6 copies all at once. So when those acts start coming back, we don't have to wait for them in serial mode, right? Like, they can all come back in parallel. And so as soon as we get to 4, we can actually, because we're a 4 of 6 quorum, and we talk about this a lot with Aurora from a durability perspective, that we picked that we needed this 4 of 6 quorum for durability. And there's lots of debate about what the right number is always on these things, right? But we don't talk about this in terms of jitter reduction that much. But by only having to wait for 4, that means if these other 2 for some reason take a little longer, you don't care.
Right.
They'll get done. We'll correct them. We'll do repair if necessary. But it means that act back to the customer happens more consistently, right?
And I remember the first time I saw this slide, Grant, had to have been maybe May 2016, that this was like I remember my mind being blown in our compute technical feedback community, and just seeing that decoupling and understanding the hows and whys. It's a game changer. There's no really other way to put it.
Yeah, and some of this was based on just things that we wanted to do because we knew the system, but a lot of it was also based on we were running RDS and we were getting feedback, that sometimes we get jitter and, customers who were super latency sensitive. And, it'd be interesting for folks, that are watching to kind of comment about, if they had those kind of experiences with databases where, they had problems where they had a lot of jitter and, was causing problems with their application.
Yeah, I also remember that one particular graph. I don't know if you have it, but the comparison was the regular database versus Aurora, and how the Aurora's I/O response is always going to be smooth.
Yeah. Well, let's actually look at that. So what I'm going to do is I'm going to switch to showing a little bit of a live benchmark
demo
here.
time.
Yeah.
Yes.
Yeah.
Have you done the demo dance yet? I strongly encourage you to do the demo dance.
The demo dance?
Demo dance. It's interpretive. It can be a shimmy, it can be a shuffle, it can be this guy. It doesn't matter. But we do have to placate the demo gods every single time.
Yes, I know. So there's always that fun. So what I'm going to run here is I'm going to run sysbench, which is just a common benchmarking tool that we use. And in this case, all we're doing is an update to the database. So we're doing a single update with a commit. So we're just measuring kind of the write latency for commit. So on the top, I have labeled as multi-AZ. So this is our RDS multi-AZ offering. And so we'll just get that started. And on the bottom is Aurora with our standard I/O offering. And this was the original offering that we had that has been around for 10 years. So what we see is we're just running one thread. So this is like not really realistic to a production workload. Mm-hmm. And we see that the latencies are fairly similar. Like the MAS is a little higher, but it's not a lot. Like 1.5 milliseconds here, if I can highlight, versus 1.2.
Yeah.
And a lot of that's coming from the fact that we're writing to 2 availability zones. So just speed of light. We'd love to fix that one, but I'm good, but I'm not that
Dark
good.
physics.
Yeah, exactly. Yeah. So this looks fine, right? Like if you looked at this, you'd say there's not much difference between those systems. But as the folks, that are watching know, real systems run a lot more work.
Yeah.
So let's run this now with 1,200 connections, which is kind of cool because, back in the day, we would need, a very, very big box to do this. And now, it's quite easily done on lots of different systems that we offer. So we've started that. It takes a little bit more time for the threads to start working. But we'll start seeing latencies. And so on the bottom, again, we have Aurora, right? And what we're seeing is, our latencies are in this nice sort of sub 10 millisecond range. Now, they're still higher. They're still up in that sort of, we'd love to see 2 milliseconds, but we're seeing, but we're also doing like 153,000 writes per second, right? That's pretty impressive, right?
Yeah, it is.
And what we see up top here, MAS also can do similar numbers, like at 150, 160, right? But we're also seeing these kind of numbers, right? We're down to 92. And our latency has jumped up to 34 milliseconds.
That's that jitter that you were talking about before.
Exactly. And this is because that's checkpointing happening, and that's causing more work for the I/O subsystem, and that can cause jitter in those systems, right? So you can kind of see that we, and again, this is at very high load. So this isn't something necessarily you're going to see all the time. This is kind of a very pushing benchmark, right?
Yeah.
Yep.
But it's the kind of thing that we like to think about because we want our customers to be able to scale and not have to worry about these kind of problems, right? So this looks quite good, right? And this is why we did what we did with Aurora. But as we've always said, we always are innovating, right? We're always thinking about what we want to do next, right? So let's just, I'm gonna stop these benchmarks and let's go back to that slide. And so what we're doing today is that commit latency is what we're talking about here, right? That's the thing we're trying to improve. And that's the difference between when you run the commit and when you get that ACK back, right? So that's what we wanted to improve even more than we'd done already. So in standard I/O, what we're doing is when that write comes down, we actually wrote to memory, and then we had to do a bit of processing to actually get it to physical storage before that ACK happened. Mm-hmm. And for a lot of applications, this is perfectly fine. But if you're very write intensive, then this takes a little more time. So about 2 years ago, we made a new offering called I/O Optimized. And at the time, this started off as I think, we did some changes to a batching so that we knew people who wanted I/O optimization would get those. Okay. But it was also a price performance. So we changed the pricing model so it was, again, better for folks that were doing a lot of I/O. Yeah. But I always had the vision that we wanted to do more with it. We wanted to continue to improve. And so just this year with version 17 of Aurora Postgres, and this will be coming out to more versions shortly, but we added this thing called the log store. So the log store now sits, and when a write comes in, it goes directly to the log store, and it's durable. So this really reduced our latencies. So let's go back and look at what that does in comparison, right? So let me just bring, so on the bottom again, standard. So if we run, again, this new IO model with one thread.
Okay.
Now, what do people think we're going to see? Is it going to be drastically different?
Yeah, what do you folks think? Let us know.
Let us know in the chat, please.
Yeah. So at one thread, as you might expect based on what we talked about, there's not much difference because it's a little faster maybe, but it's in like 0.03 milliseconds. Like most humans can't even notice that, right? But again, we're not really worried about when you're running one thread, right? What we want to be able to do is we want to be able to run something like this with 1,200 connections, right?
Okay.
So now when we're running this, so again, what we were seeing was, 9, 13 milliseconds, we were doing, 140, 150,000 TPS, right? Wait for that to stabilize. We're now seeing 300,000 TPS. So essentially double.
That is amazing.
And the reason it's double, right, is that the latency is so much lower. And when you think about that, right, for a single threaded application, how much work you can get done is directly proportional to that commit latency, right? So by reducing this dramatically, that makes a huge difference to the performance you're going to get, right? And the thing you'll notice is, the change, and this latency, by the way, is the P95 of the latency. Like the average is actually much lower than that. And so this is a very smooth, right? Like we're seeing very consistent numbers, and you'll get some, jitter here because I'm connecting remotely with my application to do this benchmark. So just, all network has a tiny bit of jitter. Yeah.
So let me see if I got this. So predictable pricing, lower latency, and higher throughput, right?
Yes.
Like this is all checkboxes.
Yeah.
I mean,
All checkboxes. I mean, I'm old enough to remember, Grant, and I'm sure you appreciate this given your background, being told, hey, I need a million IO capable database and I need it provisioned in this exact same way. And our P95 is 2 milliseconds, and anything more than that is going to be a sub-zero type of ticket.
Yeah.
Being able to get that without having to do that entire rigmarole, letting it take 18 months to get hardware, build, rack, stack, et cetera, doing that in the command line this fast with that type of performance is huge.
Right. And so what I'm showing here is at scale, and this is one of the biggest things about relational databases, that people always have a lot of fear of not being able to scale, right? So this is one of the key tenets that we work on as a team is we want to reduce that fear, right? We don't want you to have to think, I have to do something different. You just want to be able to be get a slightly larger box, or in the case of serverless, just, have it do something. So here we see
if I may.
Yeah.
Just a bit of a story, show and tell.
Yeah.
I told you I was full of surprises, and this is a true story that I promise is entirely true. I remember a couple Super Bowls ago, there was a customer that was going to do a large advertising campaign tied to the Super Bowl, and I remember getting paged the night before saying, hey, we're starting to have some issues. How can we scale? We very quickly bailed out and got onto Aurora and ended up pushing something like 4 million IO.
Yeah.
At peak, I forget how many hundreds of thousand transactions per second, and it went off without a hitch.
Yeah.
And the partner and the customer were not only delighted, they were actually kind of surprised at how easy it was for them to get going, because they were thinking, I got to get a bigger box, as opposed to changing the way they were doing things.
Yeah.
And if you go back to what Andy was saying before, or at the launch, it was, we're going to do at least as good as the open source. We have come so far away from that, we're doing better.
Yeah. And so just to kind of show you, what I was showing before was we had scale, right? But let's say you just need to do the 150,000 TPS, right? Well, now what you can do, instead of running 1,200 connections, you can run 300 connections and get the exact same performance, right? So for your application, that probably means you need less application boxes, less workers. So that saves you money as well on the system. So, and what we see now is, look at this latency that we're getting. We're getting 2 millisecond latency from the system.
Wow.
Right? So that's dramatically different. So at 300 workers, it's really almost the same as when we were doing one thread, right? And isn't that what we always want? We want a system that's very predictable, right? So if you're not pushing the very edges, now with the new IO optimized, you can get basically latencies that are super similar to what you're used to even at low concurrency. So as your application scales, which is what we all want, right? We want our businesses to keep to and need more databases. That's the positive thing about, being in this business is you want everyone to succeed. So, so now the thing that's interesting here, because this is all storage based, right? Mm-hmm. And we're running this workload, what I can go do in the background here is I can go and I can kick off a clone on this database. So this is, the command is restore DB cluster to point in time, but we have a flag here that says restore type is copy on write.
Okay.
So let's kick this off.
You're cloning while the production load is running.
Yeah, exactly.
Oh, the level of panic and sheer terror this would have inspired me 10 years ago.
Yeah. So like typically you might see, a tiny, like we might see a little bit of bump in latency, but not really. Like, the way this works is so good in that because all of it's happening at the storage layer where we do all the heat management so that these commands, whether you're doing a backup, a clone, global database replication, all these features work at the storage level, and we've done it so that there's no disruption versus...
Well, I have actually had customer conversations where customers would ask, are you certain that you're telling me that if I take a backup during production, it's not going to affect me?
Yeah.
Oh, yeah.
Yeah, and so I think those are the things that we've been working on, over the last couple of years. But as always, right, we want to do more.
You want to do more.
Yeah.
Innovate.
Yeah, exactly. So, some of the challenges that the team's working on right now, we've had some discussions around customers who put a lot of data into single clusters, right? And they like to do this, even though they can put it in more, is just a manageability. They like to have everything together. Especially when you talk about, let's say you want to do global replication or something where, hey, if you want to do a switchover, you want all those things to go with, one application, right? But the management of all that data inside that database, again, can be very challenging. And so we're working on things with the storage layer to help customers better manage large databases, have more flexibility of how they do backup and restore. So that's just, one piece of, one of the things that the storage team's working on today. And when I say storage team, really, it's not like we produce a storage feature, right? Because in the end, they're database features, they just happen to be storage focused.
Yeah, and this actually is a testament to the founders such as yourself, is that 10 years ago when you were building it, the hardware was much slower. The memory was limited, and we continue to build on that foundation, and things just keep on getting better.
Yeah.
So it's just kind of, amazing to see that what we built so many years ago, we still keep building on top of that.
Exactly. When we started Aurora, an R8 was the biggest box, right? So you look at that now and we're at 48 XLs, right? So just making those work well, that's a lot of work. When we say innovation, it's sort of like just keeping up with the future, right? Is innovation to one degree, and then leapfrogging in front, is a totally different thing. But it's what the team's really passionate about.
Yeah, and I don't think we have actually shown everything here too, right? Like this is just the basics. I know some of the things that we have added is like the tiered caching using NVMe, and that's also part of the IO Optimize. Like we just keep on going, and I think the IO Optimize reads and writes the tiered caching that was released last year. Yeah. So we're just getting started.
Yeah, and again, it's places where we think we can help customers. And that's where we really want, if you have an area that you say, hey, look, I would really like you to innovate in this. This is what we like to get back. Whether it's one-on-one customer chats or when I go to reInvent, I love those, talking with customers because we get this feedback. And sometimes we have specific, things that we're working on. We either are tweaking those or going in different directions based on that customer feedback. It really is critical to us.
Yeah, so we want to hear from you. Tell us what you want us to build next on Aurora, or the Aurora storage, and we're happy to take that feedback.
Yeah, and it's not just storage, right? Like if it's engine things, whether it's, you have a problem with, whether it's MySQL or Postgres, there's different pieces there. We love innovating at all levels, and we like to work with the open source teams because, we want to make sure that, like in general, that MySQL and Postgres continue to improve and get better. And so we like to feed back into the community those changes as well. So
awesome. Thank you so much for your time, Grant. Really appreciate it. Really cannot say thank you enough for all of the work that you've done and continue to do. Chat, we've got a survey for you. We've got a little bit of a incentive. The first 3,000 viewers who respond will get a $20 AWS credit.
Nice.
In that survey, let us know what you think about Aurora, the problems, the issues, the things you would love to see. Anything is fair game. We want to hear it. Feedback is absolutely a gift. And again, Grant, thank you so much for hanging out with us. And coming up next, we got a segment on scalability. You probably don't want to miss this one.